Okay, so we're back, and this time let's do a hypothesis test for one population mean where the standard deviation is not known. One where we're going to have to use a t-distribution this time. So estimating the p-value of a left-tail test, here's an example of that, or a right-tail test, with a sample size of 12 and a test statistic of negative 1.938. What does this mean? Well, we're going to get a t-curve with degrees of freedom equal to 11, right? The degrees of freedom is always equal to the sample size minus 1. So that's going to change the t-value that we get in this statistic, and we're looking for a rejection region with a p-value that's less than that. Now, actually, our t-value, you'll notice here, is negative, and that's because t equals 0 is here in the center, so anything to the left is going to be negative. Anything to the right is going to be positive, right? And so what we're really saying right here is that if we go in your textbook, you were to use the table, you would find a t of 0.05 of 1.796 and a t 0.025 of 2.201. Our t value, though, 1.938. Does that fall within that region? Well, estimating the p-value of a two-value test, we're actually going to take the p-value, we're going to take our t-value that we would get, and we're going to get a t-statistic of 0.0895 right here, so that means that we're looking for a rejection region that falls within these two values. Well, let's run through an example. The best explanation is one that always goes through and actually illustrates the information. So here's one. From WebAssign, you'll see a problem that says the mean value of number of sick days that an employee takes per year is believed to be about 10. The members of a school department do not believe this figure, however, and they randomly survey 8 employees. The number of sick days they took for the past year are as follows. Here they are: 10, 6, 15, 5, 11, 8, 6, and 9. So let X be the number of sick days that they took in the past year. Should the personnel team believe that the mean number is about 10? Let's conduct a hypothesis test at the 5% level. All right, so a couple of notes here that we need to make. First of all, we might ask, well, what is the null and alternate hypothesis? Well, our null hypothesis is that we're told that the mean number of sick days is that a person takes per year is 10 days per year, right? So that means that our alternate hypothesis, we're not told any information about whether that's too high or too low. We just don't believe that it's 10 days if we're the school board. So we're looking for evidence to reject the null hypothesis in favor of the alternate hypothesis that the mean is not 10 days, right? And X bar in this case represents the average number of sick days, an employee takes per year. And I know my handwriting is lovely here on this computer screen, but bear with me for a moment. Well, all right, let's put this to the test. What are we going to do? Well, the first thing that we're going to have to do is we're going to have to go back to our sample and figure out what those values are. So let's go in here and enter in the values. We have in our sample 10, 6, 15, and 5. So we're going to enter in 10, 6, 15, and 5 is our first 4 numbers. And 11, 8, 6, and 9. 11, 8, 6, and 9 as our values. Well, what does that mean? Okay, our mean is 8.75, and the standard deviation, remember here's the formula for average, and the standard deviation has to be a sample standard deviation of our sample, is shown right here. All right, so what is our claim? Well, we're going to use the one for the t-test now because this is a small size sample of 8. So our sample mean, or our population mean claim is that it's 10 days, And our alternate hypothesis is that it's not equal to 10 days. So that's our value C, right? That's we choose C to put in our alternate hypothesis. The sample size is 8, which means we have a degrees of freedom of 7. The sample mean was 8.75 as shown, and our standard deviation was 3.28416. I believe it's 416. Yes, 416. Okay, that's good. Alpha, well, we want to test this at the 0.05 significance level. So, what are we going to put in? Well, in this particular case, that means that our t-score, our test statistic, is negative 1.0765, and our p-value is 0.31738. All right, so what will that mean to us here? Let's go back to our screen and discuss what's going to happen. Our mean, right, our claim of 10 days, right, and we're looking at the average number of sick days taken per year. If we're asked to state the test distribution used for this test, if it's a t-test, what we're going to do is we're going to put t with a subscript 7 to represent a t-distribution with degrees of freedom equal to 7. Now the p-value that we got right here, 0.0034, and what we're looking at is if H0 is true, then there's a p-value chance that the average number of sick days people take is not 10 days. And I'm looking back at this value right here. I'm not sure that was my p-value. Let me go back to my screen right here. Nope, that was not the right p-value. It's 0.3174. 0.3174 rounded 4 digits. So this should actually be right here. 0.3174. All right, so that's an important point right here. I need to make sure that I'm getting the right values on the screen for you. All right, well, let's sketch a picture of it. What we're doing is we're using a two-tail test, right? So we would choose our two-tail test as a mean to illustrate that. Now our alpha level is 0.05 right here. So what can we say about all of this? Well, we are should we reject or not reject? Well, the answer right here is that we're not going to reject. Why? Well, in this case, alpha is greater than p, so we do not have enough. We do not have enough evidence to reject the null hypothesis. So the conclusion is that there isn't sufficient evidence to conclude that the number of 6 days does not exceed 10 days. Well, there we go. This was the use of our p-value if we have a small size sample. Okay, so to wrap things up for this week, don't forget that we're going to make sure you watch the Chapter 9 lecture and complete the Lecture 9 form. By Monday of Week 10, make sure that you've completed the Chapter 9 WebAssign homework and post it to the professional discussion in Discussion Board 5. Finally, by Friday of Week 10, you're going to have completed that final project. The final project covers a lot of material, and I'll put out a separate video to describe what you should expect there. Otherwise, I don't have anything else to add, so thank you all very much, and good luck on your assignments. Please let me know if you have questions.